Okay, so for this first example, uh, as illustrated in this figure below, a tornado can be approximated by a free vortex. Okay, so this is based on free vortex, which is outside the core. This is core, and then outside of this core, we can approximate the phenomena of tornado by a free vortex. Okay, so we can approximate based on free vortex of strength gamma for R higher than RC. RC is core for this tornado, where RC is the radius of the core. Velocity measurement at point A. Okay, point A, which is VA, given VA equal to 1 to 5 feet per second, and then VB is given as 60 feet over second. Okay, so it is velocity at point A and velocity at point B. Okay, so if you still remember that for the free vortex, the tangential velocity for the free vortex v theta equal to k over r. Okay, so it is inversely proportional to the radius. Okay, so that's why velocity at A is higher than velocity at B, because it is represented by using the free vortex. And then the question asks you to determine the distance from point A to the center. Okay, so this is what the question asking for, this distance. So what is distance from point A to the core of the tornado? And then why can the free vortex model cannot be used to approximate the tornado throughout the flow field, which is R less or higher or equal to 0. Okay, so first we need to identify this length. Okay, so what is the distance from point A to this core? Okay, so this is based on free vortex. So anyone got an idea how to solve for this equation? Sorry, for this example.
Triangle, sir.
Okay, okay. So based on vortex, okay, for the vortex, it is based on tangential velocity, and then k is a constant. Okay, so k is constant. So mean that for this vortex, for this streamline, you have streamline constant. So streamline is always constant. Okay, and then k is also constant. Okay, so mean that k for A is equal to k for B. Okay, so from this definition, okay, since it is a tangential velocity, v theta tangential velocity for A is given. So v theta at point A is given, which is k over RA, and then V theta B is also given. Okay, V theta B is also given 60 feet per second, which is K over the radius is from this point, which is RA plus with 100 feet. Okay, from core to the RB, which is RA plus 100 feet. Okay, so from this relation, we can determine the RA. Okay, so the unknown now is RA. We need to determine RA. So from this relation, we know that the K is constant. Okay, mean that K for A is equal to K for B. So from this relation, we can come up with K equal to V theta A R A, and then for this, at B K equal to V theta B R A plus 100, okay, 100 feet. So we can calculate RA, V tangent A, RA equal to V theta B RA plus 100. Okay, so V theta A is given 1 to 5 feet per second, and then V theta B is also given 60 feet per second. Okay, so try to find what is RA in feet. Okay, so you can get the final answer for distance from A to the center of the tornado. Okay, so any question? Soalan?
K over R berapa masuk? K over R.
Yeah, yeah. Yes, K or over R. So this is basically from definition from the vortex. Okay, so let's return to your slide. Uh, okay, this one. So for the vortex, V tangential, the tangential velocity equal to K over R for the free vortex. Okay, so I think this is from video that I uploaded last week. Okay, that discuss about vortex, force vortex, and free vortex. Okay, so tangential velocity v theta equal to K over R, where K is constant. And then for this relation, V tangential velocity omega R, this is for force vortex. Okay, omega R. So the force vortex, if in this case, it is within the core of this tornado. Okay, so we can define based on the force vortex. Okay, ada soalan lagi? So what is RA?
Dengan 2.31 feet.
92.31 feet. Okay, so ada yang dapat jawapan lain? Anyone got different answer? Nawawi?
Sama-sama.
Sama sir.
Siapa? Akilah? Akilah ada tak?
Sama sir, sama.
Okay, so ada soalan? As I mentioned earlier, this chapter you first to understand the concept of the potential flow, okay, and then just apply the equation in order to solve for example, to find the streamline, stream function, to find the potential velocity, and then to find the velocity. Okay. Ada soalan before we move to next example?
Aku rasa dah okey.
Semua okay?
Okay sir.
Okay, so move to next example. Try to read this question and then what it can be used in order to solve for this example. So basically this is for half body, the second video that I just that I uploaded in YouTube. Okay, so for the half body, basically it is a combination between uniform flow and source. Okay, so when you have a uniform flow and source, you will come out with this kind of flow field. Okay, So this is called as a half body. Okay, so for this half body, you will come out with the velocity relation. Okay, so let's see this. Slide. Okay. Okay, so this is a half body. You come up with a stagnation point, and then the width of your half body, which is pi b, okay, uh, from this point to this upper body, so it is pi b, and then also this pi b. So the total is 2 pi b. From the source point, okay. So let's say this is source point to the stagnation point. So the distance is b, okay. And then uh, in order to find elevation ataupun any point within this streamline, okay, within this close ataupun within this solid surface, we can use this equation. R equal to b pi theta divided by sine theta. Okay, r sine theta basically equal to y. Okay, so we can determine the coordinate ataupun point along this streamline. Okay. Okay, let's try to solve this example. One end of pond. Okay, so you have this pond has a shoreline, and then you have a shoreline that resembles a half body as shown in this below figure. A vertical porous pipe. Okay, so you have pipe that coming from the bottom of your of this pond. Near is located near the end of the pond, so that water can be pumped out. Okay, so water will be pumped out, so it will become as a source. And then when the water is pumped at the rate of 0.08 meter cube per second through a 3 meter long pipe. Okay, so the pipe is 3 meter long. What will be the velocity at point A? Okay, consider the flow inside the half body. Okay, so for this example, first let's list down all the given data. So the given data is Q, which is volume flow rate 0.08 meter cube over second, and with a length of this pipe is 3 meter long, 3 meter length for the pipe. Okay, so basically from this volume flow rate, okay, we can determine the strength of a source ataupun sink. Okay, so if you remember that for the source and sink, in order to determine the flow rate, it is flow rate per unit length. Flow rate per unit length equal to m equal to 2 pi r vr. Okay, so this m basically equal to q over l. Okay, volume flow rate per unit length. So m equal to 0.08 meter cube over second divided by 3. Okay, so you will get in terms of meter square per second. Okay, so this will be your m. And then the question asks you to determine velocity at point A. So what is the velocity at point A? So for this half body, okay, so let's recall the equation for the velocity. Okay, so this is the equation. Okay, so for this equation v squared equal to u square, u from the free stream, 1 plus 2 b over r cos theta plus b square r square. So this velocity equation can be used in order to determine any velocity along this streamline, okay, along at any point along this streamline. So for using this equation, okay, so v square equal,
So, question dah bagi ke?
huh?
Question dah bagi ke?
Equation saya rasa dia bagi kot. Okay. VA square equal to uh, U square 1 plus 2B R cos theta plus B square R square. Okay, so from this equation, U is not given. Okay, the stream, this one, the U is not given. Okay, so U is unknown. Okay, and then B and R. So B basically this is B, the stagnation point. Source to the stagnation point is B, and then R is radius for A. Okay, from the source, this will be uh, R. Okay, so B R and then cos theta. So theta is, what is theta for this case? Theta basically for at point A equal to 0. Okay, so at point A, theta equal to 0. So basically it is based on this question. So at this point, theta equal to 0. And then at this point at 90 degree, theta equal to pi over 2. And then this point 180 degree, pi, it is equal to pi. And then at this point, it is equal to 3 over 4 pi. And then at this point, it is also equal to 2 pi. But for this, for our example, it is equal to pi equal to 0. Okay, so cos 0 will be, cos 0 will be 1. Okay, so cos 0 will be 1. B equal to 5 meter. R equal to 15 meter. So now we still need to determine U, the free stream velocity, the uniform velocity. Okay, so you can watch a video for the half body. For the stagnation point, okay, so for the stagnation point, stagnation point is defined when the u equal to u, the coming velocity, the uniform velocity equal to radial velocity from the source. Okay, so from this definition, we can we know that from VR equal to m over 2 pi r. Okay, and then now we are equal to u, m equal to 2 pi, r is for the stagnation point, which is b, 2 pi b. So m is already defined here. So you will get m equal to 0.08 divided by 3, berapa? 0.
0.027.
0.027.
267
Yes.
0.0267 meter square over second. Okay, so 2 pi b. So you akan dapat u, m equal to 0.0267 divided by 2 pi. B is 5 meter, 10 pi. So berapa dapat? Saya terlupa nak balik ke apa nama? Calculator. Okay, so what is the answer here? The free stream or uniform velocity?
8.99 kuasa negatif 4.
Betul? 8.499 exponent minus 4, so meter over second. So this is the U. Okay, so from this U, you can just substitute U in this equation, and then 1 to B over R cos theta B square R square. So you akan dapat the final answer for VA. Okay, so any question for this example? Ni apa jawapan dia?
Cos theta tu nilai berapa sih?
Sorry?
Tu dalam formula
Cos
2.
theta? Oh, cos theta,
Theta berapa? Kosong.
theta equal to 0. Cos 0 equal to 1. Betul? Yes, cos 0 equal to 1.
Kenapa zero tadi tu?
Because at this point, A, for A, it is at 0. Okay, so we define, okay. So from the source, let's say this is your, let's say explain, from source point. So this is your coordinate, where the origin for the source. So A is at 0. Okay, the angle is 0. And then let's say you want to, let's say next point, you want to find point at this point. Let's say this is B. So at B, theta equal to, what is the theta? 90 degree, kan? So it is pi over 2. So let's say this is your C. So what is the theta here? So let's say this is at 60 degree. So this is how we determine the theta. Okay, but at point A, theta is at 0 degree, based on the origin from the source point. Okay.
Sir nak tanya, yang
Ini
tadi
apa
tu
tak ada? Sekejap. Macam mana?
yang tadi tu apa tu yang nak form equation velocity yang VA kuasa 2 tu. Tu macam nak form equation tu macam korang faham lah kat situ.
Nak form sekejap.
Jadi macam velocity untuk cari mana-mana macam general.
Oh, sekejap. Saya punya ni crash. Kat mana ni? Sini. Ya. Okey, macam mana? Tak nampak skrin lah.
Yang apa tu? Screen tak dapat lagi. Yang apa tu for yang equation VA kuasa 2 tu. Tu macam nak form equation tadi macam tak dapat nak catch up sangat lah kat situ.
Jadi this is a question from a video that I just uploaded in YouTube. Yang dah ada dalam YouTube. So you can watch that video, and then this from that uploaded video, I explain how to come up with this velocity.
Okay, sir.
Okay, so this velocity. So this velocity basically comes from the magnitude of radial and tangential velocity. Okay. So v square. So v square is a magnitude of velocity at any point. Okay. So we can determine the velocity of the magnitude of velocity at any point for the half body. Okay. But it is only valid for half body. So u square is a uniform velocity. B is the distance from the source from the origin to the stagnation point, and then R is the radius for your point. Okay, so this is how we use the velocity equation for half body.
Okay.
Okay, any more question? Ini Baba answer dia? Dia punya last final answer.
1.1332 darab 10 kuasa negatif
1.113 negative
1.1332.
power of negative
Negatif 3.
3. Ni you dah square root sebab dia ada VA square.
Dah.
Okay. So ada yang dapat jawapan lain?
Sama sir.
Okay.